Hey guys, we are back here at AWS reInvent, day 4, Thursday, and I'm here with Erik from Modal.
Yeah, it's great to be here.
Thanks for stopping by our booth. So, Erik, what is Modal?
The Modal, we're building AI infrastructures, usually how I explain it. Our thesis is basically a lot of traditional infrastructure does not work in age of AI. And all these people building AI applications, they need better abstractions. They need to work with GPU capacity all over the world. They need to scale up and down. They need to work with large models. So we basically decided traditional infrastructure, we're going to rewrite all of that. So we built a whole new stack. We support a range of AI use cases like training, inference, notebooks, code execution, powering a lot of different use cases like computational biotech sometimes, but also a lot of Gen AI, of course, vibe coding, and many other things.
How did you come to start working on this problem? I mean, I love
Yeah,
infrastructure work. It's so fun
me too.
to
I love
do
it.
the foundational
Yeah,
stuff.
yeah,
And there's clearly this like enormous transition that's happened
yeah,
around AI products and what they
yeah.
need. But how did you get this going?
Yeah, it was somewhat serendipitous. I mean, I've been building machine learning and AI products for a big part of my career. I was at Spotify for many years, built a music recommendation system there. And I saw a big gap in infrastructure for these applications, like data intensive, compute intensive applications. Started hacking on it during pandemic. That was just before the sort of Gen AI thing took off. And so we were there like quite well positioned to power a lot of these, particularly like stable diffusion was our big, first killer use case. But over time, we see a lot of things around even like protein folding, but also like LM inference, of course, training and fine tuning, and now vibe coding has been a big, super fast growing vertical for us.
In terms of building infrastructure, providing this, where kind of are you in the stack? Are you like buying chips from
No,
Jensen
no,
and
we're
racking
we're just above the
machines?
metal. So
Okay,
like
yeah. How does that fit
we're a
in?
big customer of AWS. We spend a lot of money on AWS. We run in a bunch of other clouds too. We don't want to be in the business of running data centers. We even want to do everything above. So we get the bare metals. We run code on them, and we built our own container layer. And then the idea is like basically we do everything up till the actual application. So we work with AI application developers, like machine learning engineers, basically, and they write code, they deploy it on Modal, and we manage all the sort of capacity and scaling up and down. It's fully usage based too. Kind of nice with GPUs because they're expensive. So we only charge for the time the GPUs are actually running. So kind of sit in that layer between. Our view is that GPUs, they're obviously like amazing computational machines, but you also need a software layer above to make development easy to work with these GPUs.
Can you give an analogy to maybe like traditional infrastructure in terms of how that translation works? Is it sort of like how people think about lambdas or running VMs, or like is that like a hypervisor type of thing? And like how is it different from the
Yeah,
GPU workload?
Yeah, I mean, like in a way, we're like function as a service, like the cornerstone of what we do, right? Like, so you can deploy code, and it basically acts as an auto scaling function. Unlike Lambda, we focus on very compute intensive things and GPU support and running all over the world, and actually good developer experience. No, I mean Lambda is a great product, but it's kind of hard to work with. And so where we do is we use gvisor under the hood for isolation of the workloads. I think another way to put it is that we replace Kubernetes in many cases, and Docker also. So we're like in a way like kind of a managed system that replaces all the underlying like the orchestration and the scheduling. But we own in the sense like we almost become like a cloud provider because people deploy code to us, and then we kind of abstract away the underlying clouds. So from their perspective, it's like they're running in a modal. We charge them for the time it's running. In the sense like we then arguably become a cloud provider. I would say like another analogy would be like Vercel.
I was just gonna say it sounds a lot like
Yeah,
Vercel,
it's
which
like
also is a
yeah,
big AWS
yeah.
customer. Yeah.
We're like, and Vercel is like maybe, they're more in the front end, focus, but like you can think of it as like Vercel, but like more like the AI. I mean, Vercel is like also aspirational, doing more AI, but yeah, we're like very much focused on like heavy duty, like machine learning applications.
Yeah, you're actually doing the AI IO
Well, we're
workloads and
not doing
stuff.
it, but our customers are,
Right,
right?
right,
Yeah.
right, 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 right. Across those different use cases you described, training, inference, the other kind of pieces. What are the most, I'm curious, like the most popular ones, and how do developers interface with it? It seems like the way that you would build something to do training is pretty different than how you would build something that needs to do like on-demand inference for a application for customers. You
Yeah,
know?
I mean, inference is by far our biggest use case.
Yeah.
And I think what we've done really, really well in our infrastructure stack is we have the ability to scale containers extremely fast. We can load models straight into GPUs and start containers very fast. And what we've realized with inference is you have very unpredictable demand. The problem with inference is, you have this demand which is very random. In the past, when you had to go get GPU capacity, you had to kind of buy like this like rectangular block of reserved instance, or like a set of reserved instances, and that's just not how people want to consume inference, right? They want to have this like very spiky, sometimes extremely bursty. Batch jobs is actually our second biggest use case because it's like batch scaling up and down. And so a big part of what we provide is that elasticity and the flexibility. If you need 1,000 GPUs, we can get you that within minutes or sometimes even seconds.
Wow. How much of this is hardware specific in terms of the different machines? Like, do you need to expose the hardware semantics to developers as well around what models can run on what GPUs or
We,
memory that's
I mean,
available or different
we
things?
don't really like think about models. Like we kind of let our users, they control that. Like a lot of people run proprietary models. A lot of people run open source models. From our point of view, it's just code and it's or a
They just give you the
container.
model, you run it, that's
So
it.
so
Yeah.
they can deploy that on Modal and,
Okay.
and run it. And they typically come to us like knowing what GPU they want because you have a certain model that takes a certain amount of memory. So you pick whatever GPU is like the best, big enough to fit that model, essentially. It's actually been less of a problem than I expect because there's so many GPUs out there. Like I thought it would be a big problem, like helping people pick the right GPU. But people kind of come to us and they're like, yeah, I want like an H100 or B200 or whatever.
Do they already know that it performs well on that? They already
Yeah, I
kinda have
mean,
a sense?
occasionally we help them like benchmark. We run some stuff on maybe H100 versus B200, and we look at performance. But
Yeah.
but typically our customers are very sophisticated. Like they're machine learning engineers, and like they know these things or like sort of have an understanding of it. So we help them with that, but we don't necessarily trying to like have a point of view on that. Like whatever GPU they want, like we'll help them run it on it.
Yeah. Something I always love asking, company founders about is how the business grows, like the kind of the business, not just the model, but how you acquire
Yeah.
customers. Who are you selling this to? I mean, you mentioned you're obviously here at reInvent. You were telling me before this that you're hopping on a plane tonight to go to Neurops. Are
Yeah,
you
I
selling
mean,
it? Is it
yeah.
researchers like that? Is it more like big tech companies needing the type of GPU compute? What is
No,
it?
it's more deformed. I think it sort of reflects a little bit the adoption pattern of Gen AI. I think in a way with like Gen AI, it's been a little bit upside down world. I think VCs throw us like, well, you got to go to enterprise. That's where the revenue is. The revenue today in AI is actually kind of ironically like mostly in startups. Is what we see. We see early stage Gen AI startups spending a lot of money on like running models. So we have some customers like Suno and Lovable growing extremely fast, and we manage a lot of their infrastructure underneath. Um, what I will say though is like now we're starting to see this year really starting to see a lot of sort of digital natives, whether that's food delivery or self-driving or media streaming or things like that. They are starting to adopt like Gen AI and like putting it in production and running lots of GPUs at scale. So that's becoming a very, very important. And I think that's where we're going to see most of the growth over the next few years. Eventually, of course, enterprise, right? But so they're not there yet. They're doing a lot of research on it. They have a lot of proof of concepts. I think it's going to take another 2 years until Bank of America is spending a lot of money on GPUs. But
What
give it
what
2 years.
novel use cases are you seeing? I mean, across you must have this incredible perspective across everyone doing stuff in AI.
Yeah,
I'm pretty familiar with like what a Suno or Lovable does for code generation, but what are
yeah.
some of the more surprising things that are being used or people are
Yeah,
doing?
so a lot of Gen AI inference, a lot of media, like in particular, like audio, music, video, a lot of audio transcription, speech to text, text to speech, accent coaching, like just like interesting like audio use cases like that. A lot of image, like stable diffusion, and video generation. So those are like sort of core like ICP. More recently, we've seen a lot of biotech companies using us for. I mean, it's like a company like literally trying to cure cancer, and they're doing the screening the compounds on Modal. Uh, so it's all from the whole spectrum from like face swapping to like curing cancer. It was like fun. Another company came into us the other day. They're using Modal for weather forecasting, which I find incredibly cool. So they're like literally running, ensembles of like they do all these like rollouts, basically like these simulations, right, on like one GPU each, and then they do like 1,000 GPUs in parallel, and then average that or like compute like an aggregate to look at like the probability distribution of weather over like a 10-day horizon or whatever. Extremely cool. I find it like super fascinating. I think we're also starting to see adoption in like more like physical, physics and meteorology and like stuff like that.
I mean, it's kind of the stuff GPUs were built for. Like the
Exactly.
whole
Yeah.
CUDA thing was like
Yeah.
sort of initially
Yeah.
designed around that.
Yeah. For sure.
Yeah,
Yeah.
yeah, yeah,
Totally.
yeah. Where do you think all this is going on the AI space? Like, if we're sitting here in a year talking about this,
Yeah, I don't know. I don't know. I think it's so hard. I think like there's gonna be a lot more AI, and they're all gonna need like to run the compute somewhere. Sometimes they're gonna do that through other providers, but then those providers who use Modal, sometimes they're gonna use Modal. I mean, I think like we're quite well positioned in a way like to manage a lot of that compute, whether that goes directly to our applications or through like intermediaries. we work with a lot of companies building, customer support agents and things like that, and they use Modal for the inference, for the transcription. So I actually don't know. Like I I don't know. I think that's the beauty of like same with AWS, right? Like you don't have to have a point of view necessarily on where it has to go. I mean, I have a lot of ideas. Like I'm really excited about computational biotech, for instance. I think audio is like something I'm incredibly excited about. I think we've seen so much progress in LLM. Like I feel like other modalities are somewhat like behind, but they're gonna catch up. But either way, like I think the beauty of being an infrastructure is like we'll run it all, and
We have the same thing.
yeah,
Yeah, I
yeah,
got to kind of
exactly,
see it all.
yeah,
Yeah.
it almost like doesn't matter, right?
Yeah, yeah. Last question for you, since we're at reInvent. What is this conference kind of to you? What have you been seeing? How have you been spending your time this week while you've been here?
I mean personally, like just jumping around, like meeting VCs, and to some extent, like I would say for us, like being an infrastructure vendor, like most of our customers are like not, they're more like application layer companies, and there's a lot of infrastructure companies here. So like I would say more it's like opportunity to like meet like more like partners and stuff like that. Potential companies we can work together with. We're also here to do a little. I think it was also like awareness and marketing. Like we have a booth here, and we're trying to drive awareness, but it's a long game. It's a long game. I think a lot of companies here are more in the enterprise segment. I go to Neurif later. I think there's going to be more startups there, which is like for us a little bit more of a core ICP. But I mean, I love it here. Like, there's a lot of cool stuff. I've been using AWS since 2008, so it's fun to see like how crazy this has gotten.